Okay, let's look at part C of example 3. We already did parts A and B of this example earlier in class. So recall, in this problem we have a bacterial culture that's growing according to this formula. And in this part, the culture, by the way, is we're measuring the size of the culture by its weight in grams. And then time here is the variable t. And it's measured in hours. Y is the weight of the culture. And what we want to know in part C here is when does this culture population reach 1.20 grams. So what that means is when does the Y value become 1.20 grams, right? Since y there is the variable that's representing the weight of the culture. So all I have to do is take the 1.20 and plug it into our growth model, and we end up with this equation, and this is the equation that we're going to solve here in this example. So it's 1.20 equal 1.25 divided by 1 plus 0.25 times 2 raised to the minus 0.4t power, right? This is supposed to be a 2. All right, so to solve this equation, I'm going to try to eliminate this denominator, right, from the equation. So I'll multiply both sides of the equation by this denominator. And let's see, that means then it's going to cancel on the right-hand side of the equation. When you multiply the right-hand side by the denominator, of course, it will cancel. And then on the left-hand side, you're going to get that denominator 1 plus 0.25 times 2 to the minus 0.4t power, right? You're going to get that multiplied by, let me give myself some space here, you're going to get that multiplied by the 1.20, right? And then, so that's equal to 1.25. All right, so let's distribute the 1.2 on the left-hand side of the equation. So I'm going to multiply that by both terms there. Inside the first set of big set of parentheses. So you get 1.20 times 1, so that's 1.20. And then you're going to have 1.20 times 0.25, and 1.20 times 0.25 turns out to be 0.3. So we have 0.3 times 2 to the minus 0.4 t power, right, is equal to 1.25. Now I'm going to subtract the 1.20 here from both sides of the equation. So I have 0.3 times 2 to the minus minus 0.4 t, right, is equal to 1.25 minus the 1.20, and of course that reduces to just 0.05, right? Now I'm going to divide both sides of the equation now by the 0.3, right, this coefficient on the left-hand side. So I will get, on the left-hand side, all I'll be left with is 2 to the minus 0.4 t power, right? When I divide by 0.3 on the left-hand side, the 0.3 will cancel, of course. And then on the right-hand side, I get the 0.05 divided by 0.3. And 0.05 divided by 0.3, I'm going to tell you that actually reduces to 1/6. That's really the fraction 1/6. So you could leave it written as 0.05 divided by 0.3, but I'm going to rewrite that as 0.6 as 1/6 because I think that's a little bit easier to look at. All right, now here's the key goal, right, of solving this equation. We need to get the t, the variable t, which is what we're solving for here. We need to get that out of the exponent. So the way we're going to do that, of course, is apply a logarithm to both sides. Now, since this base is 2, you could apply log base 2 to both sides of the equation. But you can just as easily apply log base 10, that's the common log, or you can apply natural log. Either one of those will work equally well to solve the equation. So since we have natural log on the calculator, and in the end here I'm going to have to give an estimate for the solution t, let's go ahead and use natural log. So I'm going to apply natural log to both sides of the equation. So I have natural log of 2 to the minus 0.4 t power is equal to the natural log of 1/6. And of course now I'm going to apply my log properties. So since you have log of power here on the left hand side, you can bring down the exponent, right, as a coefficient. So you have minus 0.4 t times the natural log of 2. And then notice on the right hand side you have natural log of a quotient, so you can write that as natural log of 1 minus the natural log of 6. And that's kind of convenient because natural log of 1, of course, is 0. Now all I have to do is finish solving this equation for t, and that's fairly easy to do, right? On the left-hand side of the equation, I'll just divide both sides by minus 0.4 times the natural log of 2, and also this on the right-hand side of the equation as well. So what I end up here with, of course, are the minus 0.4 canceling and the natural log of 2 canceling. And so on the left-hand side, I just have t, which is what I want. I've got the t isolated, is equal to, these minus signs will cancel. So I can write this as a positive value, natural log of 6 over 0.4 times the natural log of 2. So there's the exact solution. That's the amount of time it takes for this culture to grow to 1.2 grams. Of course, who has any idea what that number is, right? So we need to estimate that with our calculator, and I've done that previously before I started taping this example, and I get it's approximately 6.46 to 2 decimal places. So that tells us that it's going to take about 6.46 hours, right? Was that it? 6.46? Right, 6.46. So it's going to take us about 6.46 hours, right, for the weight of this culture to grow to 1.2 grams.